Good morning and welcome to Procon's YouTube channel. My name is Andrew Brooks. Please watch this video if you want to know more about the elastic line supports in Sumo. Looking at the properties of point supports, pad footings, and line supports in Sumo, you have the option of defining a fixed or an elastic support. When working with elastic point supports, the application is trivial. However, the elastic line supports are slightly more complicated. One of the properties of the line support is the Distribute Stiffness property. This property has a significant effect on the application of the elastic line support. To understand how this affects the line support behavior, we must first understand that a line support is simply a string of point supports. The positions along the length of the line support that intersect with a node will automatically receive an equivalent point support. For example, a simple beam split into two sections can be represented by three nodes connected by two beam elements. If a line support is added along the length of a beam, the line support will be discretized into three supports, one on each node. When we define an elastic support, we only have the one value to modify for each degree of freedom, the stiffness value. The units are kilonewton per meter for translation and kilonewton meter per radian for rotation. This value is applied differently depending on the distribute stiffness option. When the distribute stiffness is on, the stiffness value is divided between the number of nodes for each beam. Each point support along the line support will receive a weighted value depending on the tributary length for each node. With three nodes, the first and last node will have an equivalent elastic point support value of 250 kilonewton per meter. And the internal node will receive an equivalent elastic point support with a value of 500 kilonewtons per meter. Adding all the individual stiffnesses together will equal to 1000 kilonewtons per meter, our original value. If the distribute stiffness slider is switched off, then no distribution is applied. The equivalent elastic point supports at each node receives a total value of 1000 kilonewtons per meter. If you're unsure about the elastic constants applied to the line support, an easy way to find what these forces are is to export the Sumo file to Frame. In a sense, Frame displays the discretized model view of Sumo. The individual point supports can be viewed with the elastic constants applied to each of them. Thanks for watching this video. Please remember to subscribe to our channel.